Okay, boys and girls, welcome to our second video lesson in Chapter 3, our lesson on parallel lines, transversals, and the angles that are thus created by them. Let's start with Fred. Fred is a guy I know. Fred has a theorem. He says, Fred does, he says, if two parallel lines are cut by a third line, we call that third line a transversal, then three things happen. One, two types of angles are created, bigs and littles. Number two, all the bigs are equal to all the bigs, and all the yiddles are equal to all the other yiddle angles. Lastly, number three, any big angle plus any little angle will always add up to 180. So we're looking at this picture right here, what Fred says, if two parallel lines, we'll call those line 1 and line 2, if those two parallel lines are cut by a third line, this dotted line right here, we call that line the transversal, three things happen. One, two types of angles are created, bigs, which are numbers 1, 4, 5, and 8, all the yellow angles. And we get little angles, numbers 2, 3, 6, and 7. Okay? And those are all the little angles. Two types of angles are created. All the bigs are equal to all the other bigs. So angle 1 is congruent to angle 4, which is congruent to angle 5, which is congruent also now to angle 8. And lastly, all the yiddles are equal to all the other little angles. So angle 2 is congruent to angle 3, which is congruent to angle 6, which is congruent to angle 7. And lastly, the third thing that Fred says, any big plus any big plus any little is equal to all the other is equal to 180. Good thing I can talk. Okay? So again, you guys already know a lot of this because we know that 1 is congruent to 4, for example, because those are both vertical angles. Same thing with 2 and 3. Okay? We know that angles 7 and 5 are sup because those are linear pair angles. Okay? We know that angle 5 is congruent to 8 because those are congruent angles, or those are vertical. Okay? So, but now we're going to give all these things special names, but before we do, there's one more little postulate we need to talk about. It's called the parallel postulate. What we're wondering is, if I have a line, let's call it line A, and I have a point P not on that line, how many lines both pass through P and are parallel to line A? Well, the parallel postulate says for any line and a point not on that line, there is only one line that both passes through the point and is also parallel to the given line. Okay, so this point P not on the line, there's only one other line that is both parallel to line A and passes through point P. That will be important later. Okay? So right now there are 7 new ways, 7 reasons that you're going to have ways to prove lines parallel. Okay? A lot of this you already know. This all falls under Fred's theorem. Okay? But Fred's theorem is not a real serious guy. So the first one you need to know is congruent alternate interior angles yield parallel lines. We will prove this one in class. Okay, but the shorthand for that is going to be congruent AIAs yield parallel lines. Okay? These next 3, 4, 5, 2 through 5, you guys will prove in class, but the shorthands for these is congruent AEAs yield parallel lines, congruent corresponding angles, or CAs, yield parallel lines, and you remember all these angles from last chapter section. Okay, sup, same side interior, so sup, same side interior angles yield parallel lines. And the last one is sup, same side, exterior angles. You can either use the A or the angle symbol. Yield, parallel, yield, parallel lines. Okay? And you will prove 2, 3, 4, and 5 in class after I prove 1 for you. Okay? Moving on now. We got 2 more. The sixth one is almost like, it's kind of like a transitive, but it's actually a, it's not a substitution either, but this is a theorem, but they're similar to both of those. What we're saying here is if line A is perp to line C, and we see here that line B is perp to C, well, both lines A and B are both perp to the same line, so therefore they must be parallel. So A is parallel to B. Both of those lines are perp to the same line. And the last one, if 2 lines are parallel to the same line, then they are parallel. Again, this is almost like transitive, but it's not. It's like it. If A is parallel to B and B is parallel to C, and we can see those now, therefore now A must be parallel to C. Okay? Let's do some problems. Looking at this problem right here, is line A parallel to line B? Before I do anything, let's just kind of look here, and I now know that this red angle right here has got to equal this red angle right here, because those 2 angles are vert, right? So I know right now that 4x plus 5 is equal to 5x minus 1. I can now quickly solve this for x by subtracting 4x on both sides. I'm going to get 5 is equal to 1x minus 1. Add the 1 to both sides. X, therefore, is equal to 6. Well, if x is 6, I now know that the value of this angle is 29. 5 times 6 is 30 minus 1. This angle, of course, is going to be the same thing. 4x plus 5 is 29. 4 times 6 is 24 plus 5. So these two angles both equal 29, which means now these two angles, this angle and this angle, would have to be equal because those are corresponding angles if the lines are parallel, which means now 7x minus 12 is going to equal 29 degrees when x is 6. Well, 7 times 6 minus 12 is equal to 29. I'm going to get 42 minus 12 is equal to 29, which means 30 is equal to 29, and hey, guess what? That's not equal, so therefore those 2 lines must not be parallel. Okay, so we proved that with a counter example. Another type of problem is called the crook problem. What we're going to do now in the crook problems is we're always going to draw a line parallel to the 2 other parallel lines through the point at the vertex of the angle that I'm trying to find. So I'm going to draw this parallel line through that vertex at that point that's parallel to both lines A and B. Now you can see I'm going to have in red here a set of alternate interior angles, which means if this angle is 35, this angle is also 35. Likewise, in blue here, I have another pair of alternate interior angles. Do we see the big Z? If this angle is 40, this angle is also 40. So x now is going to equal 35 degrees plus 40 degrees. X is equal to 75 degrees. Trying this one, it's like a double problem. It's twice as much fun. Hey, I love it. First thing I'm going to do is I'm going to move up. I'm going to draw my parallel line. So I'm going to move this guy right to here like that. Notice it goes right through the crook. Okay, I'm going to move this guy right up there like that. He's also going right through the vertex of that angle in the middle. I now have 4 pairs of parallel lines. I'm going to draw in red the corresponding angles right here. Does everyone see that these 2 angles are corresponding angles? Do we see the big F? Okay, which means if this angle is 20, that means that this angle right here is also 20. Down here in green, do we see a big C? C means same side interior angle, so this angle and this angle must be sup. Well, if those two angles are supplementary, and this guy down here is 110, this guy right here must be 70, which means that I'm going to do a little bit of math. Hey, if this whole angle here in blue was 85, and the green piece down below was 70, that leaves me 15. Now I got one more pair of alternate interior angles. I'll do those in turquoise. We see the big turquoise alternate interior angles right there. Why didn't want that go away? I don't know, but that's okay. So those are, that's 15, which means that's 15. So now it looks like x is going to be 20 plus 15. X is equal to 35 degrees. All right, we'll try one more problem here. It looks like I'm going to have to come up with a system. It says here that line C is parallel to line D, which means there's actually at least three equations I can think of that I can come up with to figure out some equations. I'm going to need 2 because I have both x and y. Let's look right here, first of all, in this yucky green here. I know that those 2 angles are vert angles, so I know right away now that 5x plus 3y is equal to 10x plus 1. I can also say right here in blue that this angle and this angle, those are actually alternate interior angles. Do we see that? Those are alternate interior angles. So I know that 5y plus 6 is equal to 10x plus 1. And now it's almost like we're proving the corresponding angle theorem. Do we see that these 2 angles, I'll do it in red, this angle and this angle, those are corresponding angles, so they must also be equal. So 5y plus 6 is going to equal 5x plus 3y. Okay? And we just almost proved the corresponding angle theorem. Do we see that we almost have some transitivity going on? In other words, if A is equal to B and B is equal to C, then this was A is equal to C. But I just need to choose 2 of these equations to come up with a system. And let's do that. All right, I want you guys to actually spend about 3 minutes, no more than that unless you're making some progress. Spend about 3 minutes trying to solve this system. And if you can get the answer, fantastic. If not, I will go over it in class. In fact, I will give a bonus point to the first 6 people who give me that correct answer either via email or seeing me on Monday morning. All right? Have a great weekend.